Hello everyone, welcome to my channel Data Gyani. Through this channel, my goal is to provide content that is highly relevant, well researched and advanced, yet easy to understand and apply in your professional journey. If you find my content helpful, please like, subscribe and share with your friends and colleagues. With that, let's dive into the topic but before that, let me quickly share on what to expect from this video. I am going to talk about various methods of univariate forecasting. And to clearly demarcate the method, I am only using Facebook's profit model here. I am going to touch upon the intuition at a very high level and then dive into the implementation. A quick disclaimer though, that there may be more methods out there, but these are some of the common ones and they are not in any particular order listed here. The first is the simple method. It is one of the oldest forecasting methods using data where we train the model on historical data and forecast for multiple future periods, such as 30 days, 12 months, and so on and so forth. Now, it works best on short term prediction and if your data is stationary. One of the shortcomings of this model is that it has issue of error accumulation, and that's why it is not recommended for long term forecast. The next is recursive forecasting. In this technique, model predicts one timestamp ahead. Then it fed it back to the model again and predict the subsequent step. For example, let's say you have 3, 4, 5 as your historical data. The model trains on this 3, 4, 5, forecast 6, and then use this 6 into your model again and then forecast 7. This is also a very good method if you are predicting for short term, but it has an issue of error accumulation as well because it is using the forecast generated as an input. It has a compounding error effect. Now we delve into the third type, which is the direct recursive hybrid forecasting technique. Now what it does, it uses a direct forecasting technique to forecast for a period, and then it also uses the recursive forecasting technique where it forecasts step by step. It then marries both of them or take an average of both of them and then put it out like a forecast. Now this forecasting technique can be very helpful in a medium and long term forecasting because of the presence of both of the technique. We'll dive deeper into this technique once we get into implementation. The fourth technique is the rolling window technique, where we decide on the window size of say 30 days, 365 days, and so on and so forth, in case your data is in daily frequency, and generate future forecast in a sliding window manner. This method can handle non-stationarity and situations with concept drift. This is one of the recommended techniques while working on price forecasting problems for stock market, commodities, etc. We will now delve into the implementation part. Before that, I'll just quickly talk about the data. The data that we have used is from Yahoo Finance or Y Finance library, and we have taken Apple share price here for example, but you can take any of them. This is also the code where how you can fetch the any of the stock related data and use this for modeling. The first step when you delve into the forecasting is to structure your data in the right format. Now it is a dependency or probably a requirement for profit model that the data has to be stored in DS and Y format. The DS is always the date, and Y is the series that you are going to forecast. In our case, date is what is available here, the date for which you have of these values, and for series that we are going to forecast, we have chosen close from the output. It's basically um, the value at which the stock closed on that particular day, and that's what we are using for our forecasting. Next step is splitting the data into train and validation set. Now, for because our data is in daily frequency, I am using 30 days validation window, and likewise I have created my training and validation set. You can see the shape of my train and validation set here. Next up is once you have the data created in train and test validation format, you fit the model, or you initialize the model first, then you fit the model on the training data. The next step is you can use this fitted model to predict your validation, but one of the recommended step or something that I use personally is to see how well the model has fitted on my training set. For that, what I do, you can predict the model on the training data and test it on various metrics that you want to use for your validation. So I'm using RMSE, which is root mean square error, the mean absolute error, that is your MAE, mean absolute percentage error, that is your MAP, and my personal favorite, the mean directional error or mean directional accuracy. It basically tells you whether the direction of the forecast has been appropriately captured by the model or not. And I'm printing this. Then I'm using Plotly to visualize, mostly because it's very interactive. You can use any of the libraries like Matplotlib, Seaborn, any of them. So here I'm using this to for our actuals. This is our forecast, and if you can see, this is the fitment looks like. Now the blue ones are the forecast and the red ones are the actuals. You would see that some of the period has not been accurately captured and could have done a better work but we will keep that for more advanced technique. This is basic model. It has, as you can see, that I'm getting a good 91% accuracy, 1 minus, and then a decent directional accuracy as well, and a fairly good RMSE and ME. Now the next method is to forecast it on the validation side. Now for that, what I have done, I have extended the data frame, or have created a data frame that has values or dates of 60 period of future, and then I'm using that predict from my model. And next, what I'm doing, so the reason behind this 60 days, even though if you remember I have my validation window was 30 days, you will observe that there in stock market, right, you have weekends as holiday, right? So to ensure that we are and obviously the actual data will not have values for on the weekends. So to ensure that we have apple to apple comparison, we are generating data for 60 period, and then we are doing a merge here on dates to ensure that we have both y and y hat, which is actual and the forecast for the same period available. Once we have the data for the same period available, we are calculating the RMSE, MAE, MAP and MD again, and then plotting it once again. If you see, the accuracy on validation is 88%. We have a drop in the RMSE and MAE, and then the MDA looks fairly okay. Obviously, we want it to be as accurate as possible, but from a basic model point of view, it's okay. We will go into the recursive method. In recursive method, if you remember the concept, then we have to create the structure in such a way that the model generates a prediction, and then that prediction can be used back in the model. And that's what is happening here. If you see the prediction here, first of all, I am initializing the model again and fitting it into the onto the data that we have. So there was no point of, because it's the same model fitting, there is no point of showing you the fitment again. It would be similar to whatever you have seen up there. But interesting part is here, where I am forecasting for one period, future period, and then after that I'm concatenating into the data frame, and then it's getting used back again. to generate the forecast, and that's how the recursive forecasting is getting generated. Now I have kept the code for seeing the fitment as well, but as I told you that it will be similar to what I showed you earlier. I am running this make prediction on the forecast period, and if you look closely, then you'll observe that three input that this make prediction function takes is the model, the data frame, and the forecasting period. So that's what we have here. Now we are doing the similar thing here as we did up where the we are trying to ensure that we are generating forecast for the same period as or some same dates as we have in the validation set, and then that's why this merge action, right? And this is our output looks like. And then I'm simply doing the similar thing. I'm generating the RMSE map and other accuracy metrics or evaluation metrics, and this is what the output looks like. Not very good, but again there is a lot of things that you can do in this, and I'll try to cover this in future videos on how to optimize or get best out of this kind of model. The next up is the direct recursive hybrid model. In this model, again the same thing, we have the model that we have called up or initialized the profit model. The other model that we are initializing here as well is the linear regression model. Now we are using linear regression model as our direct model here, and for recursive model we are using our profit model, right? We have output generated from our profit model and then also from our direct model, and that's what you see here, right? The final output that you get is basically the average, which is something that I have covered up there as well. Let's see the output that has been generated from this. It will be again, now this has a lot of scope of optimization because you are using two models here. You can do a lot of optimization on profit, you can do a lot of optimization on linear regression model. So we will try to cover those all things in future videos. Look, this is how the output looks like. You have your y and y hat here. Obviously you have the lower and the upper bound and various other things as well. If you will like the above ones, we will try to plot it, and you will see that the plot looks something like this, very similar to the metrics that we have seen in case of recursive method. But again, because it has two models, you can do a lot of optimization there. The fourth model is the rolling window model. The first thing that you do in the rolling window model is to decide the size of rolling window. Now deciding the size of rolling window can be in an iterative process. You can also choose various, we can create a loop out of it, and there are obviously these are a lot of optimization technique which we can which we'll try to cover in subsequent videos. But for now what I have done, I have used 1044 days as or values as the window size, and then if you can see here I have again initialized the model, and then I am, it's basically like it is forecasting one point of time on the basis of this 1440 data points, and then it keeps moving in the future, and that's how it's generating the rolling forecast. So if you see this, this is how the forecast for next day look like, and then it keeps on again you need to add it into the model so that it keeps growing. So there is this concatenate step, and if you'll observe it has, so this is where it starts, the starting point of because we have 1440. If you remember, if you sum it up with this, you'll see that this period, start period, and then end date is used to forecast for the next period, and subsequently if you for next 30 days the window has on the rolling window manner the output has been generated. So this is how the output looks like. If you see the output is a lot closer to the actual value, and as I told you, right, in case of stock market, that information or the data is very related or very correlated with the nearest or the last or nearest time period or time steps. Now you have the output generated, and like I did for the above ones, I am measuring the RMSE, ME, and MAPE and MDA. You will observe the output is a lot better than the above ones. Obviously, the directional accuracy is something that has reduced, but the MAPE has reduced a lot. RMSE and ME is also something that has improved. Now this model also has a lot of opportunity of improving, um, and we can use those, or we can show those optimization techniques in upcoming videos. I am now printing all the evaluation metrics again for easier comparison between the methods, and you will observe the rolling window method is actually doing much better than the other ones. You will also observe that the simple model or the method is actually doing a little better than the recursive and direct recursive models. The reason behind this is the validation window size that we have chosen. As we increase or decrease the validation window size, you will see the outputs varying. Now, if you want to know more about time series data, its components, and basic modeling techniques, you can click on my blog link that is on Medium. And if you want to get access to the code which I just showed above, you can click on my GitHub or Kaggle link. All these three links will be available in the description. As the size of the video would have become very long, I have not covered the extensive testing technique that I use before sharing the forecast with my clients. If you want a dedicated video, please drop your comment and I can create a dedicated video for different extensive testing techniques that we use. Also, various inferencing methods that we implement before generate future forecast. For upcoming video, I am going to cover on how to optimize the profit model output using hyperparameter and regressors extracted from the series. Now, this technique will definitely boost your model performance, as we are going to use the regressor like hyperparameters in our forecasting models. If you find my content useful and want me to keep creating videos like this in future, please hit like, subscribe and share with your friends and colleagues.